Hi, Nisha.
So before starting, so can you maybe introduce yourself and the projects that you have worked upon?
Yes, I'm Rashmika and I'm currently pursuing my master's in data science from University of Washington, Seattle. And previously in India, I worked at Microsoft primarily as a data engineer. And during the course of which I kind of used Azure data tech stack to develop solutions for customers and then moved to a product team wherein I built an automated data quality system for the data of Azure supply chain. And then recently I've interned at Amazon as an SDE, wherein I built an end-to-end insights platform for Amazon influencers, wherein generated insights such as product analytics, revenue trends, some recommendations, and displayed on the mobile app. And I've during the course of my career, I've dealt with like kind of different problem statements around the data, such as building ETL pipelines, data visualization, uh, data quality, and also dealt with big data.
Okay. So basically, like we have SQL systems and we have no SQL systems, right? Like MongoDB and others. So what would be the design choice, like whether to go for like RDBMS system or whether to go for NoSQL database? So can you explain like the maybe design approach and maybe the use case related? When should you go for which system? Yeah.
Okay, so when dealing with data that is um, when you're dealing with the relational data, so it is when dealing with relational data, it is better to go for um, and also the data that can handle like a lot of transactions. It's better to go for like relational databases, whereas when we are dealing with data that is kind of like not very structured, and there is some kind of like text data or some other not just the text data, but the data is like kind of semi structured, then it is better to go for like the NoSQL database. When you have like the key value kind of structure, or like when the data is in the document format, uh, so then you can like kind of go for the NoSQL databases.
So can we use analytics over RDBMS systems as well? So if I am some analytical queries, should I go and just use OLTP system for the same?
No, for analytical queries, we should build OLAP systems. So OLAP is also it's a denormalized system. So with the relational systems, what we are doing is we are normalizing the tables so that there is consistency across the data, and like there is reliability, and that there are no like update and set anomalies. But when we're dealing with um, uh, OLAP systems, we kind of like reduce the number of tables that we have to reduce the number of joins, and we are fine if there is like some data redundancy, and there we are prioritizing like more data read compared to. So we are prioritizing like fetching data read is prioritized, whereas in OLTP systems we kind of prioritize data right. So
Any other difference that we have in these two systems, OLTP and OLAP?
mm, the structure of this is systems, it is like normalized and denormalized, uh, and along with it, uh, kind of like the scale of the data. So with OLAP we can like have like even more scale, and also for uh, basic difference would be in OLAP systems or in data warehouses, we get data from different sources, and it's like a single point of contact for different data sources, and you can like do the analysis. Whereas for data OLTP systems, it is like kind of a back end of an app, or like something that you kind of store like the transactions over. So yeah.
Any difference related to the columnar and row-based format structure?
Yes. in the OLTP, we mostly have the like um, uh, row level data storage, whereas in OLAP we can use columnar data storage. Like we can use Spark, or we can use when it comes to data lake, but we can use columnar storage to help with the fetching of data. So if there are if there are like hundreds of columns, we wouldn't want to like read all the rows and then like select columns. So we would just like want to just select few columns. So if it's like columnar, it is better in terms of retrieval of data.
Okay. Can you share your screen? I'm basically sharing one doc with you.
Mhm.
Mm, let me share. Mm. So maybe we can start with the first question. So like in this, there would be two SQL questions, and then we will have one Python question.
Mhm.
So the first question is basically you have like two columns. One is like the user ID, and
Mhm.
second column is you can consider as the login date, right? So
Mhm.
consider this as a website data where we have some user ID assigned to our name, and then
Mhm.
this is our login session information, right? So basically,
Mhm.
what we want to drive from this data, right? So we have to understand the user retention per month, right? So
Mhm.
how we will consider the retention user per month is basically, so suppose if we have been only given the data for say July, August, and say October, right? So a user will be set to have retention if he has been consecutively logging for a straight month, right? So if I have logged into July and I'm also logging to say August, then I would be considered that user has been retained, right? But suppose if I have logged in only July and then maybe on October, then for that particular month I have not been retained, right?
Mhm.
So we have to basically find in the output
Mhm.
monthly, two columns, again the month in the first column, and the second basically how many users have been retained for that particular month.
So we have to give okay.
Maybe you can go through the question, and if you
Mm.
have any doubt, we can cover. Yeah.
Okay. Number of retained users per month. Okay. Mm, then immediately the previous month. So here we have user ID 1. So uh that gets the number of retained users per month. So here we have our user ID. So one retention month is defined as the number of users who logged in that month, then immediately the previous month. So the output format is like I have the month basically,
Mm-hmm.
and um, mm, I have like the retained users, the count of retained users, and
Yes,
the
yes.
um, who's logged in the month. Okay, that's it. This is what I will be giving.
Yeah, month and the retained user count. Yeah.
Yeah. And I have like here July. So for July, 1 is there, and then for July, 3 is there. So July 2. Okay. So our output should like kind of start from for August, right? Because we don't know like if for first month, if it's we can't know like for first month, so we should start from like the second month only. So for month 8, we know that the retained users are uh, 1. So the
Mm-hmm.
count of retained user is like just 1. And
Mm-hmm.
then for month 10, okay, so if I don't have any
Yeah,
okay,
you can ignore this 10. So suppose if for any particular month we don't have any retained user, you can skip that for now.
okay, right. So this is the answer kind of for now.
Yeah, you
uh
can consider for this question. Yeah.
yeah, okay. So Okay, so what do I need to do is basically for each date that is there, or like, so I have like mm, and okay, okay, fine. Let me think. So let's say I
Mhm.
have user ID and date, and what I should do basically do is, for let's say for July month, I can see that uh, let's say there are, okay, fine. For July month, I don't know any retention because there is like no previous entry. But for June month, let's say I'm partitioning it by not June, for partitioning it by month. No, I'm partitioning it by user ID. Okay, so I'm seeing like for this particular user for in August, if a record exists in July or not. So a record exists in July. So I can say that this particular person is a retained user. So maybe I can partition it for each user, um, and based on the number of users I get, maybe I can try to just do a group by and fetch the answer.
But how you will get to know if you partition the user ID that the in July month basically that you have the user login again on the June month. So how you will get that?
Okay, so what I can do is, um, I can uh, I can fetch the basically the month from here.
Okay.
Okay, and I can do some sort of so let's say if I'm fetching the month from here, I have 08, and then uh I have 07. uh I should use some sort of window function
Okay.
basically that will
Mm-hmm.
help me to compare values um, for each user ID based on the date.
Okay.
Okay. So what window function can I use? uh so I can't use like the rank and saying all that. Maybe I can use a um um lead or lag function uh to see if the value is there,
Mm-hmm.
if the next if the next value is there or not. um mhm. So okay, so what I can probably try to do is I'll have one, and then this will have a month of 07, and then I'll have one which will have a month of 08. So this could be
Mm-hmm.
our window.
Okay.
And uh, I can try to get the like I can so what I can do is probably I can get the lag here.
Mm-hmm.
uh so if I'll get the lag here, I'll get 07 here, and here I'll just like have some 0
Mm-hmm.
month over here. So then I can compute the difference between the lag month and the current month. And with that, let's say I have another value for 1
Mm-hmm.
in 2018 10. So like, yeah,
Mm-hmm.
10, whatever. Yeah. So then I'll have this like this one. I'll have one, and then I'll have what month is 10, and then mm, so the lag of this would be the previous value. So this will be 08. So here the difference is
Mm-hmm.
1, but whereas here the difference is 2. So I should be
Mm-hmm.
selecting the user IDs where the difference is 1, and along with that I should be selecting the current month whenever
Okay.
this particular condition is satisfied. and on top
Mm-hmm.
of that I have to perform a group by to basically get like what is the month and like what are the number of retained users. How does that
Okay. Yeah.
sound like?
Yeah. This sounds good to me for now. Yeah.
So
So
yeah,
yeah.
can I write it?
Yeah. We can maybe just a bit internal logic for the window function.
Right. So so what I can write for the window function is I can select mm, mm, no extract month from date. Okay, wait. From date comma lag of what should I have for lag? Um, partition, sorry, lag of uh, the extract month from date um, over partition by user underscore id. And okay, so here I'm doing lag. So just give me a sec. So partition by user underscore id, uh, order by mm, order by solely, yeah, order by extract month from date. um Let me think about the frame clause once. So here it will come till unbounded following to range between, I'm just thinking about range one thing. So range between unbounded proceeding to current. So will I know? Yeah, I think so. Okay, as this will be as mm, my, so this is my lag, uh, um, and then I kind of have to subtract this uh, mm, mm, I have to just fetch this and month, extract month from date. So this will give me, so um can I write this in where condition select user id, extract month from date. Okay, so let me just try to, so let me just first fetch the values, then I'll subtract. Okay, as lag underscore value, lag underscore month, and this is as current underscore month from the table users.
Mm-hmm.
And on top of this I can um, just do select um, current underscore month, uh, comma count of user underscore id um, from where lag underscore month, um, where current underscore month minus lag underscore month is equal to is equal to 1, and to perform a group by um, on the um, current underscore month. So that word. Yeah, so this is what I'm thinking. How does this look?
Current month and count of sugar, month sugar ready, then count
Uh,
and the liquid percentage, then
as
then
a field come 0708.
sugar ready.
This lag month. Here underscore 1 minus underscore underscore 0.
Um, but one challenge I can think of here is like if there are say no, that won't be there because you're using lag here, right? So one, it would be zero there, and it would be distinct ID. So suppose in our final output that we want, right? We only need for month say 8, right? But
Mm-hmm.
here, when we are doing say group by current month, it will also give us the entry for say 7th and 10th with
As
zero count.
0. Yeah, I can do the ID greater than 0
Mhm.
to get only the
Mhm.
August.
Okay.
Yeah. Mm, this command. Mm, uh,
Yeah, it looks good, I guess. Yeah. Okay, so it
okay.
looks good on a high level, yeah. So we can go to the second question.
Mm-hmm. See that we have a table state streams where each row is a state and the number of hours of streaming from a video hosting service in year 2023. So year 2023, these are different months and each state has some number of streams. Write a query to get the pairs of states with total streaming amounts within thousand of each other.
So let me explain, right? So
Mm-hmm.
we have like three columns here. So
Mm-hmm.
these are like aggregated for a month, right? So for a new, say for NC, right?
Mm-hmm.
For a
Mm-hmm.
particular 8 of month, right? We are getting total this streams, 569, right?
Mm-hmm.
So then the final query, what we want is like for a particular state, we will do the total streaming within a year 2023. So for example, we have three entries for NC, like
Mm-hmm.
8, 9, and 10. So we will do a total sum, right?
Mm-hmm.
Similarly, we will do for other distinct state like CA, MA,
Mm-hmm.
right?
Mm-hmm. Mm-hmm.
What is the meaning of here? Like within thousand of each other, is it like a difference? So suppose if for NC I get like total stream for a year say 1,000,
Mm-hmm.
and for say other state CA I get 1,500, right?
Mm-hmm.
So the
Mm-hmm.
total stream difference between these two states is lying within 1,000 range, right? But suppose if I have NC coming as 1,000, but for CA I'm getting it as 3,000. So the difference is beyond 1,000, right? So that we should not consider.
Mm-hmm.
So for this final output, we are getting like NC and SC as NC entry. Why? Because if you aggregate for NC and similarly aggregate, okay, the output is a little bit different here. It should be in the final output as 1870 and CA, and it should be CA here instead of SC. Yeah. Otherwise, the output is same.
What should be in
Should be CA.
first one?
Yeah. And no, SC instead of SC, it should be CA.
Okay.
You get the question?
Uh, so within, so like we are trying first let's say we aggregated, and for NC
Mm-hmm.
the sum is 1000, and for the
Mm-hmm.
other state the sum is 2000. uh,
Mm-hmm.
I need to get the pairs of states
Yes.
total streaming amounts. Okay, so with the difference between the both of them, if
Yeah.
it's like less than 1000, it's a pair that
Yeah. Yeah.
I can have. So for MA sum is like around 4000. So for that reason, it isn't in within 1000 of either CA or NC. So we
Mm-hmm.
don't have that state over here.
Yes. Yes. You're right.
And for CA and SC, Okay. Oh, sorry. This is both. But why do we have like two entries for the same CA and CNC?
Yeah, that is like we get the
Okay.
pair of states. Yeah.
Okay.
So even if it is like a duplicate, you can consider, but we want it in our finalized.
Okay. Got it. Got it. Uh, so think the first step would be to aggregate it,
Mm-hmm.
so that we get it like on yearly, like the whole thing. Mm, then how do we perform how do we compare each state with each other's state?
Mm-hmm.
Um, each state we should be comparing within token of each other. Okay. Mm, uh, mm, okay. Just give me a second.
Yeah, yeah.
Uh, CCA. Mm, kind of, we have to do a Cartesian product.
Sorry, what you mentioned?
Oh, something like a
Cartesian. Okay.
cross join. But sorry,
Mm-hmm.
I'm just thinking out loud.
Yeah, yeah. Mm-hmm.
So
So what advantage cross join will give us?
like it maps every
Mm-hmm.
record with every other
Okay.
record. So
Mm-hmm.
so let's say I have like, okay, let me just try to group it by, mm,
Mm-hmm.
let's say I have NC some
Mm-hmm.
value 100, and then I have
Yeah.
CA some value 200, and then I
Mm-hmm.
have MA some value 300.
Mm-hmm. Mm-hmm.
So what it gives me is, for NC I'll get CA and 300, and
Mm-hmm.
for uh, I'll get like
Mm-hmm.
MA, sorry, MA as 300. And this is like 200.
Okay.
So what happens is, if we'll
Mm-hmm.
get this, I can then compare the values, and once I'll compare the values, if the difference, absolute difference, if it is 1000, then I'll be able
Mm-hmm.
to get this NCMA as one
Mm-hmm.
pair, and the
Okay.
NCCA as one pair, and similarly my CA will be mapped with NC as well, so that also I can get. Does that sound right?
Yeah, that sounds good to me.
Okay. Okay. So first step would be to basically do a um, mm, join aggregation. So first step would be to basically do an aggregation. So select um, state, comma, sum of streams um, from state streams, group by
Mm-hmm.
state, and then this we can keep as a city, and then
Okay.
probably, okay, how do I cross join it with itself? Says streams underscore dot streams underscore total. mm,
Mm-hmm.
uh so I can probably do mm, um with uh states. So select um city underscore state dot state, Um, uh, yeah.
First, you should write the join condition, I guess. Then you will be more clearer on the
Mm-hmm,
select part.
mm-hmm. Okay. So I'll be joining CT underscore states uh, S1 uh, cross join CT underscore states S2.
Mm-hmm.
Uh, there will be no condition for cross join.
Okay.
And so select S1 dot state uh, comma S2 dot state,
Mm-hmm.
um, where uh, S1 dot streams underscore total. um okay. mm, we'll do absolute S2 dot uh, streams underscore total is less than. mm, you have an absolute function in
Yeah,
SQL.
you can write ABS.
ABS, yeah, okay.
Mhm.
mm, so is less uh,
Mm-hmm.
10,000. It's not equal
Okay.
to, I should say. So I'll be selecting
Mm-hmm.
S1 dot state and S2 dot state. Does this sound good? Where single condition? Hmm.
Mm-hmm. But don't you find you need to add some more conditions? Like if you are doing a cross join here, right? So similar entry can also be mapped with each other, right?
Okay, so here my I think I should just make it distinct. Mm, just let me think once. So here I have let's say so NC is mapping with um so NC is mapping with CA and MA, and CA is mapping with NC. So if there are like three
Mm-hmm.
records, I'll basically get like 9 as well, because I think it will get like CA with CA as well, which we wouldn't want to
Mm-hmm.
have.
Yeah.
uh yeah, because that difference it will be less than 1,000 only, so that one we don't want to have. uh, so join, and I think maybe I should just write an and condition,
Okay.
where s1 dot mm, state is not is equal to, sorry,
Okay.
not is equal to s2 dot state. Then
Okay. Mm-hmm.
wait, so now this state is not is equal to s2 dot state. Yeah, that wouldn't fetch me CA and CA records. um
Okay.
yeah,
Fine.
that's
Okay. Cross join and this. Oh, sounds good. Yeah. So maybe can you open a blank sheet here?
a blank sheet. uh,
Maybe a rough because this
oh, okay,
here
just
only. Yeah. Maybe
okay.
enter. Yeah.
Hmm.
Okay. So let's take one question on the system design, right? On the modeling part. So
Hmm.
you have used Uber services, right, as well as Quick Ride and other shared services, right?
Hmm.
So suppose if we want to design a data model for the same, right? What would be the different entities that you can think of, and like what would be the different attributes that you will plan there?
So data model for like the uh, analytics, or like for the app of like Uber, like is it like the dimensional data
So you,
modeling?
yeah. So for now, just consider like you were designing some entities here.
Hmm. Okay. So for Uber, okay, we can start with um Mm, okay, so some entities we can start with are like user,
Okay.
uh, and a user can basically have be a mm, driver and the customer, uh, and uh, we can also have like Uber, right? So it's we can also have like the um, um, there's Uber, right? Different. So we can also have a vehicle. Um, it's another entity. So it can be a car, it can be a bike, or it can be, yeah, uh, different type of cars. So we can have like a vehicle entity.
Okay.
So primarily in Uber, what else do we do? um, so we have a user, and also have like a driver and customer, and then we also can have like a vehicle, and then we can have we just talk about the entities, right? So we just can have like, mm, we can also have like transactions, or
Okay.
not just the
Mm-hmm.
transactions, but actually having the connection between, we can have something like rides, uh,
Okay.
which will have the connection between which uh, y- which user or which customer is traveling in like which vehicle,
Okay.
and along with rides we can have some, mm, with rides, what else, uh, can we have a user can like book a ride, then mm, uh, hmm, we can have something related to like, uh, I think this should be good for a basic use case.
Mhm. Yeah, yeah. So in these entities, can you now think of the attributes?
So okay, so for user we'll have a ID, name, uh, phone number, and we'll also have some address, and ID, name, phone, address, and for driver, mm, we'll also have the same things, but can probably have some more specific information
Mm-hmm.
regarding driver, like, mm, just give me a minute.
Let's start with very minimal attributes. We don't need to design a whole system. Yeah.
Okay. Okay. So um, a driver can have like his vehicle
Okay.
ID that he's driving, and
Mm-hmm.
uh, uh, some kind of payment information that is like, or like his salary information or something that's particular to him, and think uh, like his driving license, or uh, stuff like that they can have, and the
Mm-hmm.
customer can have along with the generic information, some payment details, payment, or related stuff, like they can have like some account number that they necessarily like used to pay, and um, and the vehicle has ID, and it has a or it has like not a name, but probably a type, vehicle type, and mm, um, yeah, and ride. Um, Basically, rides table will have like um a user ID, called user ID or God. Um, it has a user um
Mm-hmm.
so it has a user ID, and then it has like a customer ID, and sorry, it has like a mm, driver ID and a customer ID, and also a vehicle ID associated with it, and like start date and duration, um and the cost, stuff like that. So yeah, think so far, yeah.
So in the driver and customers, do we need to associate a separate user ID with them as well?
um we can probably just have like a separate table, one for driver and one for customer.
Okay.
um it's a good practice. Just thinking. Okay, maybe we'll just like have separate table for both
Mm-hmm.
drivers and customers. Um,
But if I wanted to say fire a query, like how which particular users are registered as driver in my database, so how will I get that information?
which particular users are registered as driver?
Mm-hmm.
uh okay, if I maintain it separately, then I can just like fetch from the driver table. But
Mm-hmm.
I guess I guess I just need to join these two, like just need to have a um, mapping to it, basically. So I'll have a driver underscore ID which maps to the
Mm-hmm.
user, and I'll have
Okay.
a customer underscore ID which maps to the ID which will like keep the normal information.
Okay.
And
And suppose in this design, right, let's consider we want to normalize this as well, this design, right? And now let's take a scenario that a particular driver can have more than one, two vehicles, right? So in that case, like in the driver table that you have created, right, we will have a driver ID and vehicle ID different combinations, right? So can we try to normalize that particular table?
yes. So vehicle, okay, so vehicle, all the kind of vehicles will be in a single table, and
Mm-hmm.
maybe we can create another mm, right. So what you're telling is like, let's say if I have like multiple vehicle IDs, uh,
Mm-hmm.
I want my driver ID to be unique. It shouldn't be having
Mm-hmm.
like multiple vehicle IDs. So
Mm-hmm.
here uh, I guess like the okay. Maybe maybe create another table with like the driver vehicle um, mapping.
But would that be required, like a separate table?
Mm, hmm. I'm guessing no, but just give me a second. I'll think.
Yeah, yeah.
Uh, just like mm, hmm. So I'll basically have one driver ID and like two. Um.
Maybe think of maybe the is vehicle ID required in the driver table, or can we maybe
Oh,
somehow manage it somewhere else?
yes, yes. I think that makes okay. So, mhm. So maybe I can have a. Mm, but definitely, I need to have another
Okay.
table. So,
Mm-hmm.
mm, uh, mm, which something like
Mm-hmm.
registered or something like that. So here I can have a driver ID
Mm-hmm.
and um, a vehicle
Okay. Mm-hmm.
ID, and this maps to these two tables. Uh, yeah,
Okay. So in the vehicle, right, the ID you're mentioning that is like vehicle ID only, right?
yes.
So if I say 10, say 100 vehicles registered, right? So
Mhm.
that means like both the vehicle and the driver vehicle will have the 100 entries, right? And what will be the primary key for this driver vehicle table?
There will be another like primary key, um,
Mm-hmm.
which is kind of unique to the some like, so let's say this driver registered
Mm-hmm.
this vehicle, and like let's say
Mm-hmm.
one driver registered 3 to 4 vehicles, some like registration ID I should just uh,
Is the vehicle ID unique in this particular table?
the vehicle ID is so in the vehicle table the vehicle ID is unique. I think
Mm-hmm.
even here uh, so yes, so a vehicle ID is unique. So but
Mm-hmm.
um, one driver can have like multiple vehicle ID, so it's like not like a one to many. Okay, it's not a many to many relationship, it should be like a one to many. So like one driver can have like multiple vehicles, but multiple vehicles will not be like owned by multiple drivers, right? So one driver, like one vehicle can only owned by one driver.
Mm-hmm.
So for that reason, mm, okay, so for that reason maybe I should have the um mm, okay, so vehicle ID is unique only over here. Yes, that's correct. So maybe I can have my driver ID underscore over here,
Okay.
but I would want to. Mm, mm, yeah, I guess maybe I can have my driver underscore ID over here. Uh,
Mm-hmm.
mm, and my vehicle ID is unique, and driver underscore ID refers to the driver table, and we can have some other attributes of it over here. Does that make sense?
Do you think like in the customer you have added some payment information?
Hmm.
We would also be needed that for the driver for sure, right?
Yes, yes.
So,
So we
so
can create
mhm.
another uh, payment table, um,
Okay.
which has like some sort of like hmm, okay, so is it like, are we tracking transactions or are we tracking like, oh, just the account details? So mm, okay, let me um, okay.
What
Just
would be covered in the payment? Just take on the
mm,
different attributes. Yeah.
mm, a payment can have like um account number. And along with account number can probably have um, something like Credit card details,
Mhm.
card number.
Payment details you can say. Yeah.
Yeah, yeah, something like, yeah,
Mhm.
just the account number, card number. Uh, yeah, I think details related to that. Yes.
Mhm. And how you will link those payments, right, with the users?
Mm.
What would be the primary key or what would be the joining key?
So I can have a ID over here basically,
Mm-hmm.
and I can so for each customer it will be a unique information, each customer and like driver as well. So it's kind of like a uh, uh, one to one kind of mapping, but
But
so
one user can have more than one payment method registered as
oh
well.
yes, yes. Oh, yeah, so it is from customer to payment, it is like one to many, and from for a single payment there will be only one customer ID.
Okay.
So okay, so now I'll be having a list of mm, so now this customer can have like multiple payment methods, so how will I
Okay.
keep a track of that? uh so probably I can have the customer ID information over here as well. So I can have
Mm-hmm.
the ID and I can have the customer underscore. I mean, like I can have the user underscore ID over here,
Okay.
and here this can basically I can have so for this particular customer I have information related to uh,
Mm-hmm.
the user ID, and then this can also have information related to like the driver as well.
Okay. So you are saying the same payment table can be used for both driver and customer.
Yes, yes,
Okay.
yeah.
Okay. Yeah. That's good. That looks good for a basic design. Yeah. So can we go to the Python question in the bottom?
Okay.
So yeah, this is the one. So let me explain the question.
Mm-hmm.
So consider like in the bottom you have been given a sample array, right? Like 1011, or maybe
Mm-hmm.
it can be. So consider this array as a binary array that it will only contain 1 and 0, right?
Mm-hmm.
And always you will get an even length for this particular array. Like for
Mm-hmm.
example that we have given length of array is either 4, 6, that is even length, right?
Mm-hmm.
And the score, we want to basically get the score and consider your initial score to be 0, right?
Mm-hmm.
And what exactly we need to do is to basically select a particular index I.
Mm-hmm.
So I can be any in the length, right? So it can be 1, 2, 3, 0. It can be anything, right?
Mm-hmm.
So we have to basically pick any index. So for example, I pick index 1, right? So
Mm-hmm.
what I need to do, I need to do AI minus AI plus 1. If you go to the first condition,
Mm-hmm.
yeah. So you basically need to do the difference and add the difference to the score that we have initialized to 0. So
Mm-hmm.
suppose if you have taken index as 1, so you
Mm-hmm.
would say 0 minus 1,
Mm-hmm.
right? So
Mm-hmm.
absolute score is 1, so you will add that score to my initialized score, right?
Mm-hmm.
So basically, after doing that particular score and adding that, you
Mm-hmm.
will delete those two indexes from the A, right?
Mm-hmm.
And then whatever remaining elements that you have, you will again do the same operations, right?
Mm-hmm.
So the total number of operations that you need to perform should be exactly n by 2. So for example, if my length of array is 4, I
Mm-hmm.
should only do two operations, right? And
Mm-hmm.
my final output that I want to get is to maximize the score. So for example, if I am say doing example array maybe 0011 for example,
Mm-hmm.
right?
Mm-hmm.
And if I'm choosing the index as 1, right? Maybe
Mm-hmm.
you can note this 0011. Yeah.
Mm-hmm.
So suppose if I'm taking index 1, right? And if
Mm-hmm.
I do index 1 minus index 0, the score is 0 only, right?
Mm-hmm.
And that won't add to my score. So I should avoid that kind of operation, right? So we have to optimally choose in order to maximize the score.
And uh so what I can here do is like probably take this zero and this one,
Mm-hmm.
and then like I'll add 1 and then I'll delete these two,
Mm-hmm.
and now I'll take 0 and 1 and then add 1 and my answer will be 2. Is that
Mm-hmm. Mm-hmm. Yeah.
okay? Um,
So we have to optimally choose which particular index to choose, and we have to do this operation n by 2 times, and we have to basically optimize our score, final score. Maybe you read through the question once again just to get more clarity.
mhm. Binary array of even length when initially your score is 0. To perform the following operation exactly n by 2 times. Um, to select an index. I can only take something consecutive basically. So
Yes, that is what is the condition.
condition,
Mhm.
and it can be like the one before it or like the one after, and uh, delete AI and AI plus one from A and concatenate. Um, mm, mm, mm. After each operation, length of A decreases by 2.
Mhm.
Find the maximum score that you can get if you perform the operations optimally. Okay. Hmm.
So,
Mm.
like if we don't do optimally, we can simply do 0, 0, 0, 1,
Mm.
1, 0, right? And we get final score as 0 only. But if we perform operation optimally, like picking index 2 and doing 1 minus 0, 1 minus 0, we get the score as 2. So we have to choose, select the indexes such that we can maximize our score.
Okay. Mm.
Just think, take some time and think upon this. Yeah.
Mm. Mm. Let's have 0, 0, 0, 1, 1, 1. Then my maximum thing can be 3.
Mm-hmm.
But so, and also if I have like 0, 1, 0, 1 and like 0, 1, then also it is 3.
Mm-hmm.
Mm. Uh, hmm. Mm. So I shouldn't subtract till um till I get at least like wait, okay, till I get their sum to be 1,
Mm-hmm.
or like maybe can I convert my zeros to something, but that's still like not the chill point. Okay, let me just try to do that. uh okay, but okay, this question. Hmm.
So just think in the direction, like in order to get the maximum score, what pair of numbers that you would get, you
So
would be needed.
I would need like 0 and 1 basically. uh
Mm-hmm.
so first I should take 0 or 1 uh
Mm-hmm.
if it exists. If there is like no 0 or 1, then
Mm-hmm.
but that should also be like consecutive. There's like no consecutive 0 or 1,
Yeah.
then I
Mm-hmm.
will like add 0 to my sum and can delete like two elements. But if there is like even one single uh, adjacent 0 or 1, then I should add 1 and delete them.
But every time you are saying, say two zeros you have and you are deleting that, you are basic and adding zero to your score, you are missing out on your operations as well, right?
Yes, we should. So we should not sub. Sorry, can you come again?
So I think you are explaining that you will say if there are consecutive zeros, you will add some as zero and you will proceed
Ah,
with the remaining array, right?
I will add sum as zero if there is no consecutive one
Mhm.
zero in the entire array.
Okay, in the entire array. Okay.
Yeah, if there is so if there is a occurrence of at least one pair of zero or one
Okay.
consecutively, I will not um I'll not do an operation basically. So I understood the question. Uh, yeah. However, I'm just thinking like, okay, first let us think a brute force approach.
Mhm.
So let's say I have my zero over here, and I have the next. Okay, it's not necessarily sorted. Okay, I don't think I can have sorted because that would change the positioning. Okay. Mm. So I can kind of compare what the next element is. So if I'm like crossing this in pairs, so like I know that one is yeah. Hmm. So like this is 0 and 0, so I shouldn't be doing anything, so I'll like move ahead and I'll come here, and then
Mhm.
like I shouldn't be doing anything here also, and then I'll come over here, and
Mhm.
when I'm
Mhm.
here, I'm processing it, and
Mhm.
I now have let's say
Mhm.
I'm
Yeah.
adding one to the sum, and
Mhm.
mm, uh, okay.
One. You will have the. Mhm.
Yeah, in this sum I'll have one,
Mhm.
uh, and this two things I have to kind of delete. So I'll
Mhm.
have like the one and one. Mm,
Okay.
what I'm thinking is, so yeah, I understood like the question. So these two things I have to delete, and then like I'll just have like a zero and one. Then
Mhm.
those two things I have to delete, and here because when I'm checking 0 and 1, um like I have the pair, so I'll first delete it, and then uh I'll go till here. Let's say I
Mhm.
have some other example: 0
Mhm.
1 1 0 um 0 1. So let's say I have
Mhm.
something like this. So
Mhm.
first I found my 0 and 1. um
Okay.
so I'm going to like remove it. Okay, this will also give me the same thing. So this
Mhm.
will give, okay. um mm, okay. uh
Yeah, go ahead with your brute force approach. Yeah? So you now get 0011.
so I have 0011. So I'm just
Mhm.
like I'm thinking how to remove the elements. So I think just the um I don't necessarily have to remove them, but
Mhm.
I can let's say I have my pointer I over here and like j over here. Um, let's say after this satisfy the condition, um,
Mhm.
I'm like just going my my I will be here and my j will be here.
Mhm.
Mm, okay.
But if you would be incrementing the counters to move ahead, how you will skip these two elements?
Yeah. Yeah. Mm, okay. Let's say three zeros and three ones. Okay, wait, let me talk. So, so three zeros and three ones. So, okay, I got my first pair. So,
Mhm.
but I can't necessarily delete it. Um, oh, because that would be a costly operation. So,
It's
just
a
have
brute force, right? So you can delete.
okay, okay. So let's just say I deleted this. So here, so basically my I and j are like I is equal to 0
Mm-hmm.
and basically j is equal to 1. That's all. Like they and I'm incrementing them till
Okay.
I find at least one pair. So so my I is equal to my I is here and my j is here. Uh, and once I find, so I didn't find a pair, so I'm incrementing. So my I I and j comes here. Um,
Mm-hmm.
and this is also not a pair. And when this comes, so this is a pair. So
Okay.
let's say I'm removing these two
Mm-hmm.
elements.
Mm-hmm.
Um, mm, so I'm removing these two elements and or like kind of, let's just say marking something. Like now I'll because these two elements will be reduced, I need to like kind of like uh irrespective of it. So even if these two elements are reduced, um okay, so just thinking about how to move pointers after I delete the elements. So let's say here I deleted the elements 0
So
and
where
1.
do you want to move your pointer after the deletion?
So here after the deletion, mm, okay, let's just say deleted this. So yeah, I don't want to just like compare with my 1 and 1, right? So um I want to move my pointers like this for here.
Okay.
However, that would not work for this case because I am eliminating over here, and like
Mm-hmm.
my I and j is here, and um this should move to uh,
Mm-hmm.
or it should move to, should come
Mm-hmm.
here basically. Uh, okay.
But after you're deleting your element, say for example, we are going ahead with deleting and somehow you will design that, right?
Mm.
So in your final array, would the index would also change or would they remain same?
In the final array, okay. Oh, okay. Let's say we are deleting um
Mm-hmm.
these two
Mm-hmm.
um somehow, then the indexes are same basically. If I like not uh
So you would be doing deletion in array or you would be making a copy every time. So how you would do that?
copy. Okay. Hmm. 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 Okay, so I don't think I should delete like okay, wait. Not sure.
So basically, the approach on a high level you're thinking is so you will iterate over the array, right?
Mm.
And you will try to find for a combination of 0, 1 or 1, 0, right?
Mm.
Whatever you find
Yes.
first in the consecutive pair. Then you will add that score to your initialized one, right?
Yes.
And then you will somehow maybe delete it or maybe some other approach by maintaining the index, right? You will ignore those two pair, right? For that particular pair, and you will again the final array you get after deletion. You will again try to find the 0, 1 pair,
Mm.
and
Like
then
in brute force way, if I want to do that,
mhm,
once I'll delete this, I
mhm,
can like start from I can
mhm.
make my I comma j as 0 again,
Okay.
and I can like start from here and
Mhm,
then basically do the same thing. Um,
mhm,
so here it's not there, so I'll come till here, and
mhm,
this I'm going to delete, and uh, I know that in the
mhm,
end, like there'll at least be two elements, right? So I'll
mhm,
come here, and if they are satisfying, I'll add. So let me see how does that work for over here. So
mhm,
initially my IR and J are here. Okay, so
mhm,
now I deleted these two elements. So now if I
mhm,
deleted these two elements, it will become like this. And
mhm,
So it's like my I and j are again from starting, and now I'm deleting these two elements, and my
Mm-hmm.
array will become like this. And
Mm-hmm.
yeah, um think the yeah.
Okay.
Oh, but it doesn't sound like an optimal. It does give the
Mm-hmm.
maximum score because we are trying to find the um, mm, because you're trying to find the like the pair of 0 and 1,
Mm-hmm.
so it does give the maximum score. But let me think of something else.
Yeah.
Let me just
We try to identify the pattern, like based on the different examples you have put here, right? Try to find like how you are getting the maximum score. Is there any pattern that you have observed?
mm, whenever the pair is present basically. So
Mm-hmm. But even if you think, right, when we have like 0011, still we are able to get the score as 2.
0011, yes.
Mm-hmm.
um okay, oh right, 000.
So the pattern, so point would be
So,
like, mhm,
irrespective of okay, so let's just say I have like 00001.
mhm,
Now these two, so I just have like only one possible pair.
mhm,
In let's say I have like 111. So these two will make my one, and then these two. Oh,
mhm,
so I think number of zeros and ones matter more than um position,
mhm,
because we can change the position.
mhm,
We just need to have like, oh, okay, let's just say it's like it's all zeros.
mhm,
Um, then we don't have any number of ones, so
mhm,
it's going to return us zero only, or like we have like all zeros, or like we have
mhm,
all ones. Uh,
mhm,
let's say we have like this. Let's say take this. Now this should return me 3 because
mhm,
I have 3 ones, right? So it
mhm.
can't go more than that. Um,
Yes.
and I am like iterating and like kind of like eh,
Mhm,
concatenating it again, and I'm searching for a pair. So
mhm.
maybe I can store hmm,
So
maybe
what exactly matters to get a score here?
what exactly matters to get a score. So um, I can try and iterate in the
Mhm,
array,
mhm,
uh, and count number of
mhm.
zeros and number of ones,
Okay,
and I have to return the minimum of them both.
okay. So for example, take the scenario of the last one,
Mhm,
00001111.
mhm,
So how you would get the answer? So what you would, so suppose you are iterating through this array, right? So
mhm.
what you would get in the counts?
So I would get 4
Mhm,
for
mhm,
zeros,
mhm.
and then 3 for
Okay,
ones.
okay.
So let's say in a brute force approach, we're just removing 0, 1, and then
Mhm,
we are concatenating it in the same fashion, removing
mhm,
0, 1,
mhm,
concatenating, removing 0, 1, concatenating.
mhm.
So basically, we have done it like 3 times.
Okay.
So which is the minimum of 4 comma 3.
Mhm.
So let me think of another use case.
Okay.
Um, 0, 1, 0, 0, 0, 1, 0,
1, 0, yeah.
1, 1.
Mhm,
So here, let me think. So here I have like 3 1s and 3 zeros. Sorry, four. Okay, 4 zeros and 4 1s.
mhm.
So this will give me one pair. So I'm eliminating this, and I'm traveling till here, and this will give me one pair, 2 pairs,
Okay.
and
Mhm,
now I know like again it's the same thing. So I'll get one pair and then
Mm-hmm.
the other pair. So
Okay.
I think the just getting the sum of the four pairs, like just getting the count of the zeros and ones, and then
Mm-hmm.
the minimum of it would be the solution.
Okay. So just think like all the scenario it should work, and the condition that we have specified in the beginning, that operation should be exactly n by 2 times, will it meet that condition as well?
Hmm. It it should. So we are
Mm-hmm.
not necessarily deleting anything, and
Mm-hmm.
we are selecting the index such that it is there, and um, the length of a decrease. Okay, wait, what? The length of a decreases by 2. Oh.
So, like I was talking about the first like n by 2 condition. So, as we are doing the minimum, right? So, we will always get the number that would be like equal or less than n by 2, right?
Sorry, you're asking if like I'll be able to perform the operation. I need to do it exactly n by 2 times.
And not more than that. That's the condition.
Oh, but you can also do like less than that, right?
Yeah, yeah, yeah.
Yeah. So yeah, like
Mm-hmm.
so here this is one operation.
Mm-hmm.
Um, and then this is second operation, third operation, and fourth operation.
Mm-hmm.
Am I missing anything? Uh, sounds like mm, I think the number of operations will kind of be n by 2 only if like the number of zeros and ones are equal. But
Mm-hmm.
let's say if like the zeros are more than ones, then the number of operations will be less than n by 2, because we'll only make, like if it's like 4 and 2, we can only uh, mm, okay, okay, we can also delete. Sorry.
So don't confuse, yeah, just stick with your final solution of doing the count and finding the minimum, and just think if that would be the good solution for each and every example that you put here.
Hmm. Okay, so this would be 0 1.
Mhm.
Okay, so we have 0 and 1. So 0 and 1
Mhm.
will be one operation that we are doing. Mm.
So you
And
will get from your approach, you will get the sum as one, right?
sum as 1. Yeah, so the score will be 1 only,
Okay, yeah.
right? Because how many zeros are that doesn't, like, we can do
Mhm.
operations, but it's, yeah,
Yeah,
it's going to add 0 only. So uh the score, yeah, the score, I think
yeah.
they proceed.
This will work, yeah. This will work, yeah. So I'm good from my side, yeah, Rashmika. Thank you so much for your time.
Thank you.